Transformation of parent functions. F of x is going to be our y. If I add outside my function, it's going to shift my graph up c units. Because I'm taking my parent function, I'm adding c units to it. C is going to be our variable I'm going to use. Now I'm subtracting c units. So it's going to shift c units downwards. Now when I multiply c units on the outside of fx, it's going to be a vertical stretch by a factor of c. Now since c is greater than 0 but less than 1, when I multiply it on outside of fx, it's going to be a vertical shrink of c. Now if there's a negative outside of fx, it's a vertical flip. It's always going to flip over the x-axis. These first 5 problems are a vertical transformation. The last 5 problems are horizontal functions. The horizontal change happens inside the parent because you're doing something to the x before you put it into the function. So if I add c to x before I put it into the function, it's going to shift left instead of to the right. Now we're subtracting c from x. We're going to shift right c units. Now since we're dealing with horizontal functions, when we multiply our c with x, c is going to be greater than 1. This is going to give us a shrink horizontally by a factor of c, which means you're going to come towards the y-axis. Now if we multiply x by the small number, it's going to give us a stretch horizontally by a factor of c. And if we change the sign on our x, it's going to be a horizontal flip, but it's going to be over the y-axis. There are many parent functions, but the famous 8 are the linear and quadratic, absolute value, square root, rational, inverse, exponential, also known as the reciprocal function, and then constant function. In this example equation, the vertex is 0, 0. And y equals the absolute value of x. We plotted the vertex on the graph already. The expression is between the absolute value sign and it's at its lowest point, 0. For instance, y equals the absolute value of x minus 3. Since we're dealing with an absolute value equation, the plot is going to look like a V. Anything inside the absolute value sign is all we're going to deal with. In this equation, x minus 3 equals 0. So x is going to equal 3. From now on, 3 is going to be our anchor point. So I'm going to make a chart to help fill in with several numbers greater than 3 and several numbers that are less than 3. Okay, so where we learn x equals 3 and y equals 0. So you're just going to fill in the chart as if it was a number line with only positive numbers. So now we're going to fill in the bottom half of the chart. We already learned when x equals 3, y equals 0. So now we're just going to fill in the chart with the rest of the numbers, just like a number line. Okay, so now we're just going to plot all the points on the graph. And as you see, it made a V shape. Okay, and now to finish the problem, you could put the parent function back on the chart. As we learned, y equals the absolute value of x, and the child, as I like to call it, equals y equals the absolute value of x minus 3. It's shifted to the right.